Hello, this is Mrs. Smith, and today we are going to work on an example for parallel circuits. A parallel circuit is going to have a voltage source, and I'm going to set it at 18 volts. This is the symbol for a battery. Parallel circuits have all of the resistors hooked up so that they are running plus to minus. And what I mean by that is on the voltage source I have a plus and a minus. So each resistor is going to be plus to minus. Okay. This is R1, R2, and R3. R1 is going to be 5 k ohms, R2 is 1 k ohm, and R3 is 900 ohms. To find the total resistance in a parallel circuit, you have to take the inverse of the sum of the inverses. So the easy way to put that in your calculator is you take 5 k ohms inverse plus 1 k ohm inverse plus 900 ohms inverse, and then you have to inverse the answer. To actually put that in the calculator, for those of you who are learning the engineering notation, you're going to put in 5 second E3 inverse plus 1 second E3 inverse plus 900 inverse, and then inverse it again. Okay. Your answer should have been 432.69 ohms. And a check on a parallel circuit, your total resistance is going to be smaller than the smallest resistor. The smallest resistor in this circuit is 900 ohms, so 432.69 ohms makes sense. Okay. The second thing you solve for in a parallel circuit is going to be your total current. That's IT. Total current is the current that's leaving the source. It looks like this. Okay. You get IT by applying Ohm's law. If you remember, Ohm's law is V equals IR. Okay. I can use my circle here. I'm going to cover up my I, and it's going to be equal to voltage divided by resistance. So I'm going to use my total voltage divided by my total resistance. My total voltage is 18 volts. My total resistance, I just calculated, it's 432.69 ohms. When I put that in the calculator, I get 41.6, and it'll say E negative 3. That E negative 3 means milli. The correct unit for current is amps, so it'll be 41.6 milliamps. The next thing you'll need to solve for is IR1. Okay. Your total current here hits this node and it splits. The current that comes down this branch is IR1. Okay. You're going to then go back to your Ohm's law. I again is V divided by R. So I'm going to take my voltage at resistor 1, divide it by the value of resistor 1. In a parallel circuit, one of the rules is that the total voltage is equal to the voltage in branch 1 is equal to the voltage in branch 2 is equal to the voltage in branch 3. So my 18 volts that I have here as total, that is the same voltage I have in this branch, which is R1, the same voltage I have in this branch, R2, and the same voltage in this branch, R3. So my voltage at branch 1 is going to be 18 volts divided by the value of the resistor in branch 1. That's going to be 5 k ohms. When I put that in my calculator, 18 volts divided by 5 k ohms, that's going to be 3.6, and it'll say E negative 3. That E negative 3 means milli, and my unit for current, again, is amp. When I solve for IR2, it's going to be the voltage at resistor 2 divided by the value of resistor 2. So again, 18 volts divided by 1 k ohm. That's going to give you 18 milliamps. Again, on the calculator, it'll say 18E negative 3. The negative 3 means milli, and the unit is amp. IR3 is equal to VR3 divided by R3. So that'll be 18 volts, because VR3 is equal to VT, divided by 900 ohms. It's the value of R3, and that will be 20 milliamps. Okay. You have to verify Kirchhoff's current law, which I'll call KCL. Kirchhoff's current law states that in a parallel circuit, the total current, and I'll write it out here, the total current is equal to the current in branch 1 plus the current in branch 2 plus the current in, this would be branch 3. If I had more branches, I would keep adding. Okay, so I'm going to take 41.6 milliamp, or no, excuse me, I'm going to take 3.6 milliamps, the current in branch 1, plus 18 milliamps, the current in branch 2, plus 20 milliamps, the current in branch 3, and I'm going to add all of those up, and they come out to be 41.6 milliamps, which, if you look from up here, was my total current. So that tells you that your work is correct and that your circuit has been solved. Thank you.